Hello everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. As the continuation of the lecture series in the topic two-dimensional random variables, in this lecture video we are going to see what is covariance. So covariance is nothing but the study of relationship between two variables, say x and y. So it is calculated by using e of xy minus e of x e of y, or f of xy minus f of x f of y, depending on the type of random variable we are using. If it is a continuous random variable, we use f of x. If it is in a discrete random variable, we use expectation. So here is an understanding of covariance. What we are going to see in this video: first we are going to see the definition of covariance, next properties, interpretations, and how we can use this covariance in real life. So here is the covariance definition. So covariance is nothing but the relationship between two random variables, say x and y. So this covariance is divided into three types. The first one is positive covariance, which indicates that both the variables, if x increases then y also increases, if x decreases then y also will decrease. Next is a zero covariance, in which it says that if x is 0, there is no relationship between both the variables. Next is a negative covariance, in which if x increases then y decreases, if y increases then x will decrease. So next, magnitude, it reflects the strength of the relationship between two variables. So here is the decision thinking based covariance. So first one is the understanding the significance. First we need why to use this covariance. So this is to recognize the importance of covariance. Next, consider user perspective, incorporate user needs. Next, a practical solution will be discussed. Next, enhancing the understanding, deep and comprehension of covariance. Next, exploring covariances and all is discussed. Next is empathy part. So in this empathy, why we have to use this. So utilizing covariance in practical problems. So understanding the implications of positive negative values of the covariance. So covariance misunderstanding, mostly this covariance is misunderstood as lack of rigor or knowledge gap. So here is the covariance relationship in variables. So variables increase together. Next is a linear relationship. Next is a variable move in opposite direction. Then it is a non-linear relationship. For example, if it's a positive covariance, then it will be a linear relationship. If it is a negative covariance, then it will be a non-linear relationship. So here is the real world applications of covariance. So in signal processing, this covariance technique is used to reduce noise. Next, in image processing, it is a proper extraction method in which the images are processed. Next, in machine learning, models are evaluated using this covariance. Next, in finance, risk management, risk assessment can be done using this covariance method. Next is diversification. So this also reduces the overall portfolio risk. This is used in calculating portfolio variance. Next, it is also used in determining expected asset return. So here is the multi-phased applications. So in signal processing, it is used used for analyzing and processing signals. Next, in control systems, for optimizing control systems, we can use this covariance. And in image processing, enhancing images through covariance based techniques. Next, in machine learning, it is used to improvise the models. So here is what we have seen in the covariance. So first we have discussed what is covariance, then positive covariance, zero covariance, and negative covariance. Next we have studied what is magnitude. Next, the real life applications in finance, signal processing, machine learning, and engineering are discussed. And also we have discussed the DT based concept of covariance. Next, how this is misunderstood in some cases. So here is the assessment question. If covariance of xy is 0, then there is no relationship between, that is, it is also known as uncorrelated. Next is, in covariance helps to determine the direction of relationship. Next, covariance matrix is always symmetric. So here are the references. Thank you.